In this video, we are going to learn how to calculate the molar mass of a gas. So when we are calculating the molar mass of a gas, we have to realize that this molar mass is the same numerical value as the molar mass that we would obtain from adding up the atomic masses from the periodic table. The molar mass of a gas is constant. It will not change even if pressure, volume, or temperature is changed. Molar mass is unique to the gas that makes up the gas. Molar mass, we know, has units of grams per mole, meaning we can calculate it if we know the mass in grams of our sample and how many moles of gas are in that sample. This moles of gas is what we're going to be calculating using the ideal gas law. So if we take our PV equals nRT Pivnert equation and solve for N, we get N is equal to PV over RT. Then we take this and then plug it into the denominator of our molar mass equation. And then we get this complex fraction, which we can then simplify. Anything in the denominator of the denominator really belongs in the numerator. And so we have M times RT over PV. Also, do you remember when we were calculating empirical formulas and molecular formulas, and we needed the molar mass in order to go between the two? Well, now we have a way of obtaining the molar mass experimentally. Let's go over an example of this. It says a 200 milliliter bubble, so that's my volume, containing 0.283 grams, that's my mass, of a flammable gas at this pressure and this temperature. What is the molar mass of the flammable gas? So I'm going to convert my temperature into Kelvin before I get going in my calculation, because I know that anytime I do a gas calculation, my temperature should be in Kelvin. I can calculate my moles by doing PV over RT. And so, let's see, pressure was 0.951 atm. Volume was that. I'm going to have to convert that into liters by dividing by 1,000. 0.280 liters. My R is 0.082058 liter atmospheres per mole Kelvin. And then my Kelvin temperature is 298.15 Kelvin. So I can calculate my moles of gas now. 0.951 times 0.280 divided by 0.0. I'm not sure what happened there. 0.951 0.280 0.08258 times 298.15. Okay, so my moles of gas is 0.10883 moles of gas. So my molar mass is equal to my mass in grams divided by moles. And so that is 0.283 grams divided by 0.10883 moles. So we just plugged that in down for moles. So I'm going to go ahead and store this number in my calculator. Now I can hit clear and do 0.283 divided by my moles. and that tells me my molar mass is 26.0 grams per mole. I just need 3 significant figures because that had 3, 3, 3. Lots of things have 3 sig figs, so just 3 significant figures there. And so there's my molar mass of my gas. Here's a practice problem for you. If the flammable gas from the previous example, which had a molar mass of 26 grams per mole, is 92.3% carbon and 7.7% hydrogen by mass, what is the molecular formula of the compound? Go ahead and pause the video and work that out. Unpause the video when you're ready. We have 92.3% carbon and 7.7% hydrogen. So if we had 100 grams of this, we would have 92.3 grams of carbon and 7.7 grams of hydrogen. Then we convert each of these into moles. So we have 92.3 divided by 12.011, 7.6846 mole C. I'm not going to round for sig figs yet, because I'm not done with the calculation yet. So that's 7.638 mole each. And so I got to divide both of these by the smallest. And that's going to give me about 1 for each of these. Well, that one's exactly 1, but the other one's about 1. It's going to be really, really close to 1. So that means my empirical formula is CH, 1 of each. 1 carbon and 1 hydrogen have a molar mass of 13 grams per mole. And our molar mass was twice that. So molar mass of molecular formula is twice that of CH. Therefore, my molecular formula will have 2 empirical formulas in it. And so that'll be C2H2. That was a great review problem. Now let's try to calculate the molar mass of this gas. Go ahead and pause the video and try to work out the molar mass of this gas on your own. Unpause the video when you are ready to check your work. Okay, so we do not know what the gas is, so we're going to have to calculate this experimentally. This is my mass. This is my volume. And this is my temperature. I'm going to go ahead and convert that into Kelvin. And so it's 338.15 Kelvin. And then this is millimeters of mercury. Find its molar mass. So we could convert this into ATM, or we could use the R value that's for torr, that's on your yellow sheet, because a millimeter of mercury is a torr. So let's go ahead and figure out how many moles of gas we have. I'm going to go ahead and use we know that our molar mass is grams per mole, and That's going to give me my mass in grams over my PV over RT, which will be my mass in grams that's my mass, times RT over PV. So I need to take my mass in grams, 0.244 grams, and to match my unit of pressure, I'm going to select the R value, 62.36 liter torr per mole Kelvin. And then that is torr. Then my temperature was 338.15 Kelvin. And then my pressure was 924 torr. And my volume was 0.310 liters. So that is 0.244 times 62.36 times 338.15 divided by 924 times 0.310. And so our molar mass is 17.96. And I need 1, 2, 3, 1, 2, 3. Well, these are going to be 3. So that's going to round up. And so that's going to be 18.0 grams per mole. That's my molar mass.